Hey guys, welcome to the podcast where I'll try to make the NCERTs easy to retain for both of us. Whenever you feel like you don't have much time or you just want to multitask, just come back here on Spotify or on my YouTube channel, Learn My Podcast. So I conducted a poll asking you all which class and subject should I start from. And you chose, I wish there were drum rolls here, but class 9th science. So let's start there. The first lesson is matter in our surroundings. We all know that matter is something that occupies space and has mass. ये तो बचपन से रटते आ रहे हैं. Which means that it has both mass and volume. The question that arises is matter continuous or particulate? Well, it's definitely particulate. Or we can also say that it's made up of particles. As when we mix salt into water, it becomes invisible to the eyes. कहाँ चला जाता है भाई? Well, the particles of salt gets between the particles of water. And that's why I said matter is particulate in nature. Also because I have the book open right in front of me. But let's continue. And I should say that particles of matter is very small. Like very, very small. Even smaller than your will to text back your ex. Anyways, we should move on and talk about the characteristics of particles of matter. These particles have spaces between them, and that space is known as the intermolecular space. And let's think of them as the restless kids, always in the state of motion, always, which means they've got a lot of kinetic energy, and which is directly proportional to the temperature. As temperature increases, the kinetic energy also does, and vice versa. Because of this constant motion, we see phenomena like diffusion. We'll talk about it in the future, but if you still want to know, Google it. Just kidding. Intermixing of particles of two different types of matter on their own is called diffusion. And on heating, the process becomes faster. The temperature increases and then the kinetic energy does. So that way. Now the particles, the restless kids, are very good friends. They have a force of attraction amongst themselves, which is called the intermolecular force of attraction. And this force varies from one kind of matter to another, based on which we divide them into three categories. We all know them, the popular three: solid, liquid, and gas. We'll take them one by one. Let's start with the solid. Solids have definite shape, distinct boundaries, and fixed volume, and they cannot be compressed. They maintain their shape when compressed, so we can call them rigid. Next in line is the liquid state. They have no fixed shape but have fixed volumes. They take up the shape of the container they are put in, so we can call them as the shape shifters of matter. They can flow and change shapes, so they are not rigid, but they can be called fluid. Many gases like carbon dioxide and oxygen diffuse in water, which is essential for the survival of aquatic animals and plants. They actually breathe the diffused oxygen present in water. Solids like copper sulfate, liquids like ink, gases like oxygen, they are all able to dissolve in water. So we can conclude that solid, liquids, and gases can diffuse into liquids. Well, the rate of diffusibility decreases as we go from solid to liquid to gas. as the intermolecular spaces increases amongst themselves. Waving from the back of the line, we all can see gaseous. They are highly compressible, and due to which large volume of gases can be compressed into small cylinders. A few examples are LPGs and CNGs. LPGs are the cylinders you see in your household, and their full form is liquid petroleum gas. On the other hand, CNG, commonly used as fuels in automobiles, is compressed natural gas. Now the gas molecules are always on their phones while driving, so they are moving in random directions at high speed. They keep crashing at the walls of the container they are put in. And this force, exerted by the gas particles per unit area on the walls of the container, is the pressure exerted by the gas. Also, because of this high speed and large spaces between them, they diffuse very quickly into other gases, which is exactly why the smell of the tasty cooking reaches you even after you are sitting very far from it. So in this world full of solids and gases, be a liquid. Now, can matter change its forms? Yes. Like all the people who you considered friends but turned out to be snakes, matter also change its states. You see, it's all about the temperature. As temperature increases, the kinetic energy also increases. Particles vibrate at high speed, and intermolecular force is overcome by the energy supplied. Solid particles leave their fixed positions, and a stage is reached when solid melts and converts into liquid. This process of conversion of solid into liquid is known as melting, and the temperature at which this process happens is known as the melting point. And melting point of ice is 0 degrees Celsius or 273 Kelvin. Reverse of this exact process happens in freezing, where liquid turns into solid. And now we increase the temperature furthermore. The kinetic energy also increases, and the intermolecular force of attraction that remained during melting is overcome by the heat provided. The particles start escaping the vessels, and the liquid finally converts into gaseous. This process of conversion of liquid into gaseous is known as vaporization. Reverse of vaporization is condensation, where gaseous converts into liquid. And if we were actually doing this experiment with a burner, thermometer and other instruments, we would have noticed that when the temperature reaches the melting or vaporization point, the temperature didn't rise, but the process is still happening. The ice is still melting, the water is turning into gas or water vapor. This heat, used up by the matter for the change of state, is called latent heat. Latent meaning hidden. Hidden from thermometer. Maybe they were playing hide and seek and a definition was formed. So, the amount of heat energy required to change 1 kilogram of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Because of this latent heat of fusion, kinetic energy of water at 0 degrees Celsius is more than the kinetic energy of ice at 0 degrees Celsius, as the kinetic energy of water is inclusive of the latent heat of fusion. Similarly, the amount of heat energy required to change 1 liter of liquid in gas at atmospheric pressure at its boiling point is known as the latent heat of vaporization. And have I mentioned the difference between boiling and evaporation? I guess not. Boiling is a bulk phenomena, while evaporation is a surface phenomena. And boiling occurs at the boiling point of that liquid, whereas evaporation occurs at any temperature. There are some substances that change directly into gaseous form from solid state. They are called sublimable substance. And the process by which the sublimable solids converts into gaseous state is called sublimation. Reverse of this process is called deposition, where gaseous of these sublimable substances converts into solid state. A few examples are camphor, ammonium chloride, naphthalene. These substances actually skip the liquid phase, just how we skip our homeworks. We have learned about how temperature affects the change of state of matter. As a matter of fact, pressure also affects the change of state of matter. If we apply pressure and reduce temperature, we can liquefy gases like solid CO2, carbon dioxide. It's stored under high pressure. And when we release the pressure and bring it out to 1 atmosphere, solid carbon dioxide converts directly into gaseous state, which is why it's also known as the dry ice. Hence, from now on, we will not forget pressure while considering change of state of matter. Justice will be served. I already introduced you guys to my friend Evaporation, right? Let's get to know him a little better as to why it is the way it is. See, at any temperature, you will find particles of matter with different level of kinetic energy, be it solids, liquids, or gases. In case of liquid, the particles at the surface have higher kinetic energy and are able to break away from the force of attraction, forming vapors. And this happens at any given temperature, below the boiling point of course, and called, evaporation. Evaporation causes cooling effect, as the evaporating water molecules absorb energy from the surrounding to convert itself into gaseous state. This absorption of energy makes the atmosphere cooler. And in summer, we should wear cotton clothes. No, this is not a fashion advice. We are still on the NCERTs. Hear me out. We know that water in our sweat will evaporate and absorb energy and make the surroundings cooler, right? Now cotton, being a good absorber of water, will absorb the sweat and expose it to the atmosphere for easier evaporation. Also, have you noticed when you put ice in a glass and leave it on the table, the water droplets appear out of nowhere on the outer rim? It's not magic. It's all about the latent heat. The water molecules present around the glass loses their energy and gets converted into liquid on coming in contact with the glass, as the glass is cold enough, and we see water collected on the outside of the glass. There are a few factors affecting evaporation. First is the surface area. As the surface area of the liquid increases, the rate of the evaporation also increases, as it provides a larger area for the liquid molecules to escape. For example, we spread the clothes when we put them out to dry. That's to increase the surface area of the clothes and hence increasing the evaporation. The second is the temperature. As the temperature increases, the kinetic energy of the particles also increases. And then more particles escape. That means the rate of evaporation increased again. Thirdly, the humidity. Humidity also affects the rate of evaporation. You can think of humidity as the amount of water molecules already present in the atmosphere. And if humidity increases, the traffic in the air also increases. And lesser number of water molecules would like to go there, which results in the decrease in the rate of evaporation. But if humidity is low, then traffic is less. More space for water molecules to enter. So, the rate of evaporation increases. In short, the rate of evaporation is inversely proportional to the humidity in the atmosphere. Humidity increases, rate of evaporation decreases. The last is the wind speed. Wind speed also affects the rate of evaporation. As the wind speed increases, the humidity decreases. So the rate of evaporation will increase and vice versa. Oh, and did I say that there are 3 states of matter? Sorry, my bad. There are in fact 5 states of matter. 2 of them were discovered in the near past. That is plasma and Bose-Einstein Condensate. Plasma is actually super energetic and super excited particles. And they are in the form of ionized gases. Fluorescent tubes and neon signs consist of plasma. The gases present inside them gets charged when electricity flows through it and create glowing plasma. The color of these signs and tubes is determined by the type of gas used. Plasma exists naturally in stars because of the very high temperature. The stars glow because of the presence of plasma. The other one, the Bose-Einstein Condensate, is formed by cooling a gas of extremely low density, about 1/100,000th the density of normal air, to super low temperature. The BEC was first predicted by Satyendranath Bose and Albert Einstein in 1920. In 2001, Eric A. Cornell, Wolfgang Ketterle, and Carl E. Wayman from USA received Nobel Prize in Physics for achieving Bose-Einstein Condensate. And with that, we come to the end of the first episode of Books Do Talk. I hope you enjoyed it. And I'll be back with a new episode in the near future. But till then, share it with someone who's having trouble trying to retain the NCERTs. Who knows? You might actually make their day and their life easier.